Hello and welcome back to Print 101 at Fullerton College. This is Professor Ben Hewitt. Today we're going to talk about screen printing, which is chapter 20 in our textbook for class. Screen printing is one of the more approachable forms of printing out there, and it produces a lot of really fun things that people really enjoy producing and having once they've made. So let's get into talking about screen printing. So screen printing uses a fabric mesh. They call it a mesh, a fabric of some sort that is porous, and you're able to force ink through the fabric, kind of like a stencil, onto something below your substrate. This is where you're going to have the most varied substrates of all, because a screen doesn't really care what kind of ink you're using or what kind of substrates below it. It's very forgiving both on ink use and on surface texture below. You can screen print onto clothing, which is otherwise unheard of. You can screen print onto wood, metal, plastic, anything you want. And many of these things are done professionally that way. So the things you need, the equipment necessary for screen printing. You need a screen fabric of some sort. You need a frame to stretch that fabric over. You need a stencil made somehow. There are many ways of doing these things. You need ink. The ink should match your substrate. The type of ink that works well on, let's say, t-shirts is actually really bad for paper. I once tried to do a poster using t-shirt ink and the ink came back off the paper. It just peeled right off after I tried to cure it. So your ink needs to match your substrate or it's just not going to stick. It's like trying to paint with watercolors on, a piece of wood. You're just not going to get good results. Anyways, you need ink. You need a squeegee to force it through. You need something to print onto. You need a substrate. Otherwise, what's the point? So you can see here in our little image on our slides that you can see on this one, it involves a film positive and a light sensitive emulsion, which is one of the common ways of doing it, the way we do it in our lab. So you coat the screen in a chemical that when exposed to light, it hardens. When it's not exposed to light, it stays liquid and it's water soluble while it's still liquid. So you put a film positive in front of it, you expose it to ultraviolet light that cures everything the film is not covering, and whatever the film covered is still wet. So then you can spray that out with a hose, rinse out the extra emulsion, and you have a hole. Well, not really a hole because there's that porous mesh in there, but you have a hole in the stencil where the ink can go through. The squeegee helps you force the ink through evenly and make sure you get a good bond to the substrate below.
For any sort of light exposed screen, you need to create a film positive. I'll pull this off the wall for us here. I like this one for some reason. Kind of cute. Anyways, a film positive has blacked out areas where you want the ink to go. That way when you expose it on the exposure table, that'll block the emulsion from hardening and you'll be able to wash that area out and make the spot in the screen where the ink goes. Our vacuum exposure table system. This lets us expose screens much more efficiently and much more in a controlled environment where you can control how long and how much light it gets. The top of the thing lifts up. It's kind of like a tanning bed for your screens. The screen goes on face down. You close the lid and turn it on. And as it turns on, you can see the blue light. This is ultraviolet light coming out. Again, kind of like a tanning bed. You don't want to look directly at that in person, but there's something about ultraviolet light that is addicting to humans. You see that light and you want to look at it, even though it is actually hurting your eyes. So here's the screen we've made for our printing technology department, and you can see on it, I'll even hold it to the light, that you can see right through parts of this. The parts that you can see through are the parts where ink and liquids can go through. The orangey parts and the red parts, which are made out of emulsion and blocker materials, were cured by the ultraviolet light on the curing system, and they will not allow ink to go through. So when you squeegee across this, ink will go where you see the holes. And again, those holes were made using the blackout of our film positives. So remember, when you're making silk screens and you're making a positive to go expose on a table, black is not the color you're printing. Black means yes, ink here.
let's talk about squeegees because there's different shapes of squeegees and they do different things for you. So squeegees, if you get the right angle of squeegee to screen, as you can see in the bottom right of this image, the correct angle causes a perfect or the best print you're going to get. The optimum screen angle will give you the optimum print. And that means that the ink does not squish out and spread. You can see it on the right when they're pushing too hard on their squeegee and it's bent too hard. You can see that it causes the ink to spread out and not just go straight through. You want the ink to go straight through the screen and not to go out and then balloon and spread and stick to things. That wrecks your image quality. You lose your fine details. If you're doing halftone images, it makes everything too dark and impossible to see. The shape of the squeegee also affects this because the sharper the point on it, the more you're going to be able to achieve the one on the left, where you're getting very fine detail, but the less ink is going to go through. I'm sorry I don't have a third image showing not printing enough ink, but that's also possible. If you have too vertical of an angle and not enough squeegee, you're not going to be pushing much ink through and it will give you a bad print. But anyways, you have the trade-off between very sharp squeegees and very rounded squeegees. Sometimes you want the round ones to put a lot of ink through. If you're just really trying to get thick coverage and not do fine detail, then a rounder, flatter squeegee is good. If you're trying to do fine details, you want a sharper squeegee. I can also show you that right here real quick.
Ah, the humble squeegee. This is how you force ink through your screens. Now, we typically have square edge ones here, but they come in different shapes, from round to pointy to square. The square is a good compromise between the round edge and the pointy edge. The pointy edges come to like a knife blade point of the rubber on top, and that gives you a very fine, accurate print, but at the cost of not forcing much ink through, so it's hard to get good coverage. The round edges, when you have them, they look more like the handle, kind of a rounded top would give you a lot of ink, but with very fuzzy edges. It just doesn't give you the same crisp detail on the smaller parts of the design. A square is really the halfway point between the pointy and the round.
Okay. Talk about ink additives. So the ink has to be kept at the correct consistency. You want it to be sticky and pretty much like a, well, we'll say this a couple times, kind of like a peanut butter, but not like a Jif peanut butter out of the jar, but one of those natural peanut butters where they grind the peanuts in the store in the back in the, health food kind of places and or that aisle in the grocery store. It's a bit more soupy, but it's not so drippy that it drips off, and it's not so stiff that it doesn't drop. It's a it's a very specific thing, very specific consistency you're looking for, and it'll change depending on your substrate on the ink. But there are additives to do things such as make it dry slower, make it dry faster, make it runnier, make it stiffer. You're able to basically adjust the drying time, and you're able to adjust the viscosity, the consistency of the ink. There's also wash up solvents, and those are things you just use to clean up and get rid of it. You use that to wash things off at the end, and that gets rid of all the leftover ink films. You also need a drying system. Screen ink has to be able to stay liquid for long enough to stay on the screen and be forced through. If it dries too fast there, it's just going to ruin your screen. So that means typically it's done that it requires additional drying. Here's a picture of the different types of ways heat is transferred. Oftentimes, and especially with plastisol t-shirt inks, your ink needs heat to cure. A lot of times it needs to heat up to have a chemical reaction called polymerization, where it turns into a hardened plastic surface from the liquid that you first print with. Some screen inks will never dry on their own, so you can leave them out, not that you should, but you can theoretically leave them out for weeks and weeks on a screen and print with it whenever you want it. So long as you don't cure it at the high temperature necessary, it stays liquid. So the three types of heat transfer are conduction, convection, and radiation. Conduction means one thing is hot and it's touching something else that's hot, and the heat just goes through everything that's touching it. That's not ideal for drying ink because that means you're going to be smearing the ink on things touching it. Convection involves moving air or moving water, where the ambient, not necessarily atmosphere, but the ambient conditions outside the heat also cause the heat to spread. Convection ovens work this way. They blow air around and circulate it to cause the heat to transfer quicker from the oven to the food. And then there's radiation. This is not the kind like in Chernobyl with the Geiger counters and nuclear accidents. This just means the heat will come off of something and things nearby are warm. Most heaters work this way, especially the old radiator heaters in the schools like I grew up in. You just have that little metal thing on the wall, don't touch it, it's hot, and the whole room heats up, kind of like a toaster oven. Let's talk about screen frames. Let me show you this on a separate video. I have a few things I shot in the lab for you. And okay, so with that frame, we also have something called off contact distance. If you lay your screen flat on top of what you're printing and print straight through, when you try to pick your screen back up, it's going to be stuck in the ink you just printed, and it's going to smear it and smudge it and cause all sorts of yucky problems and make your stuff look bad. And you don't want your stuff to look bad. So there's something called off contact. You want to keep the screen hovering above your substrate. And when you press down with a squeegee, you force the screen to stretch just a little bit and push onto it and apply the print. And then when you let go of the squeegee, it pops, bounces back up. Think like a trampoline kind of physics here. So the lower the off contact, the less image distortion. The higher the off contact, the more, because it has to stretch more if it's higher up. So you want to get just about, when I say a nickel, I mean a nickel lying on its side. The proper distance above for a good print is about the width of a nickel. Again, a lying down nickel, not a standing up nickel, off the substrate. That way you don't stretch it too much, you don't distort the image, but at the same time it springs back up and doesn't stick to what you're printing. Let's talk about screen fabric. So screen fabric is going to affect your print as well. Depending on what type of project you're doing, you want different fabrics. They all do different things for you. Let's talk about the types of things. There are different weaves that will come to haunt you in our book and our quizzes. Taffeta, twill, and gauze. Taffeta is the best for fine detail printing, but it's the weakest print. Taffeta is the thinnest you can do with a fabric. That means you're doing a single strand of fabric or thread woven over and under only once. Twill involves a slightly different weave where you go over and under sometimes more than one in a row, and it makes a stronger fabric and a little bit thicker. Khaki pants are often done in a twill, and a lot of uniforms are done this way as well. It's a little bit thicker, a little bit more durable, but at the cost in screen printing of accuracy. And gauze, like a medical gauze used to absorb things, means you have lots of layers all kind of interwoven on top of each other. And it's really not my favorite for screen printing.